Hi, in this video we want to keep digging into our data using pandas, and we're just going to go over some stuff that I haven't hit so far and hit a little bit of nuanced stuff. It's going to feel similar to the stuff we've done so far, but that's okay. It's a little bit windy outside. I'm on my patio in my backyard enjoying the lake. Hopefully you can hear me. If you can't, let me know. I'll remake the video. All right, so here is my pandas script, or my Python script. And of course, first thing I'm going to do is set up my working directory. Then I import pandas and I load my data set. All right, so remember that PD is a standard abbreviation for pandas. That is the standard way for loading in a lot of types of data. Here is the file path. I don't need the full file path because I'm basically, by setting up my working directory, I'm already calling this as a suffix over here. I'm telling it to skip 4 rows because there's 4 rows of not useless stuff on that spreadsheet. And I want worksheet SG, standing for school grades. Now, down here, if you recall previously in a video, I went through and I got rid of all of the spaces, all of the characters in the column names. It's good practice to not have any punctuations, special characters, blanks, tabs, spaces, or anything like that in names of objects, including column names. So I just go ahead and remove those, manually put that in. Now here, I'm going to be doing some plotting. So let's go ahead and get matplotlib.pyplot in. We use the standard abbreviation of PLT. All right, so now, if you recall, we've got histograms. Histograms give me a bar plot of the number of times that a variable appears in a certain range of values. So here we can see that this tall part corresponds down here. So let's see, we've got, this is probably what, 5, 10, 15, 20. So here, all the values that appear here are between 15 and 20. All the values that are in here are appearing between 20, 25, 25 and 30, and so on. All right, so, it kind of gives us, an idea of the density. Kind of looks a little bit bell-shaped, not quite. Now here's the part that I want to point out next. All right, so here, this is a cumulative distribution function or cumulative density function, depending on if you're dealing with a continuous variable or discrete variable. And when I look here, you can see that it's increasing as I go from left to right. And it goes from 0 to 1. All right, what this is doing, this is telling me, like, what is the probability, what is the empirical probability of having a value less than or equal to 40? What is the empirical probability of having less than or equal to 60? What is the empirical probability of having less than or equal to 80? And so, when I say empirical, it's just the observed frequency, proportionately. And you'll see that in this data set, 100 is the maximum value. So we have a probability of 100% probability that it's going to be less than or equal to 100. All right. And so why do we like these? These curves help standardize distributions. When I look at it in this format, it's not as standardized. Usually this is a format we usually like. These are usually easier for people to understand, but there are certain cases, such as in hypothesis testing, when I want to compare two densities, that this curve is more useful because it's always increasing. It's usually more important for hypothesis testing than for actual decision making. All right, now I want to kind of dig into the describe function for a moment. If you remember, I'm hitting F9 every time I come to a line. If I put .describe on the end, it goes through and it grabs all of my numeric variables, and it goes through and it gives me the summary statistics. It's describing it. So it gives me a count of the non-missing values, gives me the average for each column, the standard deviation for each column, minimum, maximum, the median, 50% quartile, then the 25% quartile, 50% quartile, okay? And it does that for all my numeric variables, quick and easy. Now, one thing that we can do, let's say that I'm not really interested in different variables. I can subset my data just like we've done before. And I can specify only the columns I want by putting in the names or the index. Remember, indexes start at 0. Also, I have control over what are the percentiles I'm going to put in. So here, 0, 25%, 50%, 75%, 100%. Spits it out. Now you'll notice that it does minimum actually twice when I put in 0. It does the maximum twice when I put in 1. That's how it works out. Now something else I can do, let's see, let's make this a little bit more interesting. Let's say that, let's go 33 and let's go 67. When I do that, you'll notice that I have these not in order, but Python goes ahead and puts them in order for us because that's probably what we actually want. Now, the next part, notice that I put in include. All right, and here this represents a data type. Check out what happens when I do this. So I'm going to put describe, I put include equal to the like O with apostrophes around it. All right, what this did, this included only the categorical data. And what it does, it goes through to each one of my categorical columns. It gives me the count of non-missing values, gives me the number of unique distinct values. So here, there are 76 districts in the school grades file. Now, the most frequent one is Miami-Dade. That's not very surprising. And it gives me the frequency. So I know that in 2019, there were 443 schools in Miami-Dade School District that received a school grade. Now, if I look, you know, if I print the whole thing out, I'll get all the columns. It only gives me the first and last to kind of summarize it. If I look at the alternative ESE center school column, there were 3,341 distinct observations. There are 3 unique values. By far the most common was no, because yes and no are the 2 main ones. And then the frequency was 3,335. So, you know, the vast majority of the values are an N, for no, for not being an alternative ESE center. All right, well, now let's do something very, very similar, but instead of include, let's go exclude. All right, so what I did here was this is equivalent to grabbing the numeric columns by saying exclude the categorical ones. And then it just goes through and does the default thing. I could also have gone through and I could slap in percentile into there. Let's do that. Because we're wild and crazy people. Let's do this. All right, so now you notice I've got percentile and I say exclude. So do not do anything with the categorical data. Give me the percentiles off of this, and we can see that does it all nice for us. It's beautiful. It's beautiful. All right, now let's say that I want a 95% observation interval. So this is not confidence interval. This is an observation interval. This is, I want to know where 95% of my data is lying within. So this is a good way to kind of establish cutoffs for outlier checks. So district number, well, the district number is actually categorical, but it's recorded as numeric. So this is a crap column, you know, for this purpose. But this one is interesting that 95% of the economically disadvantaged students column go between 12 and 100%. So it goes all the way up to 100. So this tells me that this is probably going to be skewed left data since it goes all the way up to the maximum possible value. All right, now let's take a look at unique values. So this is something that I do all the time at work, is I print up what are the unique values, because a lot of times when I have a larger data set, I've got values in there that maybe they're not in there correctly. For example, I was working with school grades data, not school grades, student grades data, and I had approximately 60,000 students times maybe, probably about 8 for each student on average, something about that. And so, I've got a lot of values. And so, I had a different semester, at different quarters, I had different trimesters, I had final grades, I had a whole bunch of stuff. And I need to see like what were the unique values in there. In my special case, for this problem, I had letter grades that were A, I had letter grades A with a period. What was the period there? I don't know, never figured it out. Another time I had B's, and I had B's with a period tacked on. I had C's and a C with a period tacked on. The period was doing nothing, so I had to go through and manually remove them. How did I find them? I used a unique statement to see what are the unique values. So when I say unique here, what this is going to do is going to go through and it's going to find what are all the unique values, and it's going to print them out for us. So we can see that we've got 1, 2, 3, and 4. And this is being stored as an integer. That's what the int means. That's what its data type is. All right, so I know that there's 1, 2, 3, and 4 in this particular column. Now I know from prior knowledge about this data set that 1 is elementary school, 2 is middle school, 3 is high school, 4 is other. So that helps me understand what's going on. Now something that I might be interested in is how many elementary schools are there in the state of Florida? Well, this data set won't tell me, but I know when I look at this, there's 1,818 elementary schools in the state of Florida that received a school grade during 2019. So I have an idea of how many there are. Now, that does not include private schools. That does not include special centers that did not receive a school grade. That does not include mixed grade level schools also, because that's the type 4 schools. All right, so how did I get that? All right, so what is going on here? I've got school grades, I've got the column I'm interested in, I've got this one, and the part you really need to pay attention to is this double equal sign. The double equal sign tells me that this is not an assignment, this is logically, are these equal to each other? The double equal sign, are these logically equal, is what I want. So what I can do, if I was to run this as is, you'll notice that it's a whole bunch of trues and falses. When this column value is equal to 1, it spits out a true. So we know the first 5 rows are elementary school in the data set, and now when it's not a 1, it's a false. So I know that the last 5 rows are not elementary schools when I look at them. All right, so now I'm interested in how many middle schools are there. Let's execute that. So I'm using the sum function. All right, so what's going on with this? When I put sum on a logical vector, a true gets added up as a 1, a false gets added up as a 0. So then what it's telling me is how many times the school grade, school type logically equal 2. So when it's equal to 2, add it up. And we know that there's 572, and 2 corresponds to middle schools. Okay, next one I want to know about is high school, right? So let's do that. So there's 478 in the data set. Now, how many other schools are there? When we say other, these are going to be schools that have a mixture of grades. So they have some from elementary, some from middle, some from high, and some combination. They have at least 2 different levels. So it could be like a 5th grade and a 6th grade. It could be a 5th grade through 9th grade. Could be an 8th grade and a 9th grade. We have a whole range of mixtures. Most of the time in this data set, it's going to be grades below 9th grade because in the state of Florida, because of the accountability system, high schools have a much greater accountability scrutiny because of graduation, and a lot of like charter schools and private schools just don't want to deal with it. So they kind of avoid that stuff. All right, so I know there are 473. All right, so one of your peers in the class was asking, hey, how do I get bar plots for my categorical data? I've already answered him. Thank you for the question. I really do appreciate it. What we need to do, we have to go value counts. I have to take the vector and I need to count up the number of times each of the levels appears. So let's take a look at that. Let's just do value counts for now. All right, so what it goes through and it creates a quick and easy table for me, giving me the values that we've already looked at, that there's 1,818 elementary, and then 500 something middle, 400 something high, and 400 something other levels. Now what we're gonna do with this new data, so what this does, this part that's highlighted creates this part, and this is a new, it's either a dictionary, so what, yeah, it's either a dictionary or data frame. I can't recall which one it is. I have to call it. But I just tack on plot kind equals bar. Let's do this. And now it spits it out for us. So I can see that by far, elementary school is the most common. That should not surprise us. And then middle schools, there's slightly more than high schools. And then high schools and other mixture of grade levels are close to each other. All right, so now, what if I want to subset my data? So if I want to start digging into this, it does not make sense to do an analysis on, that includes elementary, includes middle, includes high. For my analysis, these are definitely different populations. So I need to split them out. I need to get them apart. So what I'm going to do, I'm going to make an index. What is going to happen is I'm going to make an index right here. I'm going to make it an index as true and false when the elementary school, when the school is an elementary school, and I'm going to record it here. And I'm going to call it index underscore elementary. Now what I'm going to do, I'm going to use the .loc. So I'm going to take the location function and I'm going to pass it into the row position of my data frame. So remember, it's always rows before columns. I've got the brackets, then I have my index, then I'm using the colon to say I want all columns. If I don't have this, I need to go through and actually name the columns that I want. And something that's important is I'm using the location operator for this. So I'm hitting F9, and now I'm going to hit describe, and so now this spits it out. Now let's take a look at what happens. I'm going to do the same thing I did here on school grades, but now I'm doing it on the elementary data set. If I did this correctly, if I did what I intended, this is going to be 1,818 because I grabbed all of the elementary schools. These three will be 0 because I left all of the elementary schools behind when I did this. So let's do that. Let's go F9. All right, that's good. 0 because I didn't want any middle schools when I executed this. 0, that's good. Didn't want any high schools. And 0 because I didn't want any mixture levels. And so I can go through and do this again. So if I want to get just the middle schools, I'm going to create an index of true and false, indicating when I have a middle school. And then I pass that index into my data frame, indicating which rows I want to keep. So this goes through each and every row and gives me a true if it's a middle school on that row. It gives me a false if it's not a middle school on that row. And let's just go through, and now I'm doing the same thing for high school, other. Now I've got that. All right, so that's interesting, that's exciting, that's fun. Now what I want to do, I want to make a histogram. I want to look at a histogram of English language arts achievement and mathematics achievement. This is the column that indicates, did the kid pass the state test, yes or no, for English and for mathematics. Okay, so there's some things going on. Notice I have this alpha of 0.3. What this is a transparency parameter. I'm telling it as I set this number, makes it so that the plot, the color is transparent, so I can see through them. So I'm able to see through the two histograms. And you'll notice, because I have two variables in here, I have two histograms on top of each other. If I don't want them on top of each other, I need to go through and make subplots, which we'll talk about later. In this format, it's easier to see that, you know, if two histograms have the same like distribution and the same average when they're on top of each other. If I have them like this on top of each other, or, you know, two plots vertically, or have two plots horizontally, it's not as easy to see those differences. Here, it's a little bit easier to see if I'm doing something like hypothesis testing. All right, now you'll notice I did that for the entire data set. Let's do this for elementary. All right, so we see that there's kind of a U on English language arts, which is kind of interesting. It's kind of surprising. But math appears to be kind of a bell shape. And let's go ahead and look at other. A lot of times, if you subset your data, you'll start getting more information out of your visualizations if you reduce it down to an interesting population to build it up on. All right, that's all I've got for today. I hope you're doing well. I hope you're staying healthy. Let me know if you have any questions. I took a look at the data sets that you posted for your first homework assignment. I'm excited to see what you guys get. You guys have you know, really gone in and got some interesting data. I'm really pleased by that. In the past, I've had students just kind of do the same data sets over and over and over. You guys are definitely not doing that. You guys are mixing it up. I'm enjoying the class. Take care and bye.